Hello everyone, welcome back to Inside Electronics. So today I got some free time and so I decided to do some small experiment. And for that I'm using this common mode chalk, and I hope you guys are familiar with these kind of things because this is a common part in almost all SMPS circuits. The duty of this thing is to prevent the switching noise from getting back to the AC mains line, and they're actually used in series with both the phase and neutral, and you can find them as a common item in almost all quality made SMPS circuits. They are not so familiar in the low quality SMPS, but look at this is a mean well power supply, just for example, and you can see the size of the common mode choke that they're using in here. When comparison to this one, you can see the number of turns are different, and also the thickness of the copper they are using is also different, because obviously this has to handle a lot more current than what I have right now in my hand. So this is actually a branded power supply. It was made by Meanwell, and I have another example here which uses almost the exact same part as what I'm having, and these two are exactly the same, but the one that I have is from some other circuit which I don't know where it is right now. And one more example is this one. This is an SMPS from an old computer monitor, and you can see the common mode choke in a different shape. So overall, you can find them in almost all like well-built SMPS circuits. And as I said, the duty of this thing is to isolate the switching noise from coming back to the mains line. So here for the experiment, I'll be using it as a 1:1 transformer, because you can use these two as a primary or these two as a primary. Like it's a 1:1, you can use either one of them as primary, the other one will become the secondary. And as a load, as I said, I can only use an LED. In the circuit, it's actually used in series, which I already explained. It's used in series with both the line and neutral. These two will be series to one line, these two will be in series with the other line. And right now what we are going to use is we are going to use this as a transformer. So one pair will be the primary, which we are going to connect this function generator, and the secondary we'll be loading it with an LED. So right now I'm going to connect this function generator to this 1:1 transformer, this common mode choke by the way, and it's kept at 5000 Hz, and you may hear a small humming, like whistling sound right now. Can you hear that? It is making a noise because I can hear that because I'm much closer to it. Not sure how well the microphone has picked it up, but it becomes audible when it comes down to the 1 kilohertz range, like 1 to 2 kilohertz. It becomes quite audible. Again, I'm not sure how well this is getting picked up by the microphone, but up to 1 kilohertz, 1 to almost 2 kilohertz, it is audible. And let me give it a try once again. Not sure whether you heard it or not, but it is creating that 1 kilohertz tone right now because it's acting like a speaker. Okay, so let's begin the experiment. Right now I'm going to keep this at 1 kilohertz, and when I connect the LED to the secondary, which has now become the secondary, you can see the LED is now on. And if I adjust the amplitude, the frequency, it will work to a certain point beyond which it will get dimmer, and you can see it is AC because the LED is lighting up either way. And because these kind of things, it's actually creating a resonance to give the maximum output, and it can work for this particular choke. It can work up to 5 kilohertz without any issues, and above 5 kilohertz the LED is actually getting dimmer. It's not going any brighter, it's getting dimmer. And the lower side, when I try to check how low it can go, you can see right now I kept it at 100 Hz, and the LED is slightly glowing. It is on, it is glowing, but it's very low. That's because it's not resonating with the current material properties of that choke, the ferrite that is used in that choke. But go anywhere up to 5 kilohertz, from 1 kilohertz, like from 1 kilohertz to 5 kilohertz, it will work just fine. And you can see the LED. Let me show you once again. Let me increase the frequency a little bit more. Let's set it to 1 kilohertz, and let me show you once again that here you can see the LED is much brighter. So here you can see that we can indeed use these common mode chokes as a transformer, because after all it's just two pairs of coil of wire. So I don't have any application for these kind of things, and I'm not sure whether we can where we can use it basically, because it's just a very lossy transformer. And anyway, since we did this much, let's go ahead and measure the voltage and the voltage losses that's happening in the primary and secondary. For that, let me get my multimeter. Just 1 second, please. So here's my multimeter. So let's measure the primary and secondary voltage. Note that I'm keeping the multimeter in AC mode, and if I measure the primary when it is loaded, it is showing 1.7 volts at the input, and at the output or the secondary it is showing 1. If I can make the connection properly, it is it's not showing, it's showing 1.6, so almost a 100 millivolt drop between the primary and secondary. Right now you can see 1.9 because it's a no load condition. The LED is not glowing. If the LED is not connected, obviously there is no load, and hence the voltage will rise. And you can see the frequency right now is 1 kilohertz at the primary and 1 kilohertz at the secondary, so frequency will not change depending on load. That is a common fact, but the voltage will change. So if I connect it right now, you can see 1.7 volts, and if I remove the LED right now, if I remove the LED, we can see right now it's off. 1.9 volts, it gets to 1.7 when the LED is connected. So it is loading the primary also, and because of these properties we can only use it for very low voltage applications, because if you connect a larger input voltage, the you will either burn the common mode choke or you will burn your power source, because it's going to draw a lot of current. There is very low resistance in here. In fact, there are not a lot of applications for these kind of a DIY 1:1 transformer. It could be useful for someone who is looking for some kind of application, some kind of alternate application for these kind of things. I just made a video so that if it's helpful for someone, let it be like that. Anyway, thank you for watching guys. See you with another video.